Reimer-tiemann reaction. In this reaction, we can simply convert phenol into salicylaldehyde or orthohydroxybenzaldehyde. In case of a Reimer-tiemann reaction, whenever we treated phenol with chloroform and sodium hydroxide under heating, it will provide, suppose we have phenol, whenever treated with chloroform and sodium hydroxide on heating, it will provide orthohydroxybenzaldehyde, or this is otherwise called salicylaldehyde. This reaction, most important thing, the mechanism of reaction is proceeds through reactive intermediate carbene, which is electron deficient species. Initially we have sodium hydroxide, which undergo to provide Na plus and OH minus. Now we have chloroform CHCl3. Due to electronegative effect, this bond became weak, so this one is more acidic. Hydroxide from sodium hydroxide will attract this H plus, and this bond shifted to carbon atom to provide carbanion, and this one became water and will generate carbanion. After that, one of the chlorine atom will remove as a chloride ion, and due to creation of positive charge and negative charge here, it will cancel each other and it will form CCl2. This is a dichlorocarbene. It is electron deficient species which is act as an electrophile, and we have chloride ion. This is the most important point, dichlorocarbene. Now we have phenol, which will attack dichlorocarbene, which is an electron deficient species, because it contains, suppose CCl and Cl having 2 electron, so it contains 2 to 4 to 6 electron, deficient of 2 electron. Oxygen having 2 lone pair, it will goes to this place, and now this bond will attack to electron deficient species, the pi bond, which is loosely held. Now we have double bond takes place here. After loss of lone pair of electron, it will acquire a positive charge. Initially it contains hydrogen. Now we have CCl2. After the attack of this pi bond, this one will acquire a negative charge, and this bond goes to this place to minimize the positive charge. This carbon will acquire a positive charge. Now this bond goes to this place, and removal of H plus to attract by this negative charge. Initially this bond goes to minimize this positive charge, and this carbon will acquire a positive charge. To minimize this positive charge, this bond shifted to this place, and hydrogen is taken by this carbanion atom. Now we have this is OH, and the bond is formed due to transfer of this bond, and now we have CHCl2. When this compound undergo hydrolysis, then this part of this compound like CH, Cl and Cl, whenever it go hydrolysis, this negative part will attach with H plus, and this partially positive charge attach with hydroxide. At this side it's same, this negative part is attached with H plus of water, and this partially positive side will attach with hydroxide of water. Then it will form, with loss of 2 HCl, it will form in this type of compound. As we know, the carbon containing 2 hydroxyl group is not a stable compound, so this bond goes to this place. This bond shifted on hydroxide ion, it will become converted into a water. After loss of water, this compound is converted into, this one became carbon double bond, oxygen and hydrogen. This is orthohydroxy benzaldehyde or salicyldehyde.